Hello friends of Stefan. You might be surprised to see me here and not Stefan. There's a sad reason for that. Stefan passed away in January after a short yet severe illness, just at the age of 69. I'm Marcus, Delta Lima 4 November Lima, and member of the board of the local DARC Ham Radio chapter Munich-South. Stefan was member of this chapter, and since his retirement 2019, he acted as our technical advisor. Stefan was rather active in the ham radio community and gave presentations both in Munich at the Amateur Radio Conference and also at the Weinheim VHF conference, where he also chaired some do-it-yourself competitions. He was always spreading the knowledge about ham radio, so he was part of the team presenting radio transmission at the Deutsches Museum, a permanent exhibition for technology and science in Munich, and very active on YouTube, as you all know. He always had an open door and an open ear for anyone who needed technical assistance, and supported many of us with his extensive technical knowledge. With Stefan, Delta Lima 7 Mike Alpha Juliet, we are using a dedicated club member, an enthusiastic radio amateur, and a good friend. Rest in peace, Stefan. We, from the local club board, did attend his funeral and have now, after some reasonable time has passed, also contacted his family, where no one has a personal interest in ham radio. We are now preserving his ham radio heritage as good as we can. We secured his YouTube channels, his website, and will also take care of that devices which were sent to him for repair, and will return them to their owners whether repaired or not. In this context, I have taken care of the MFJ 998 tuner, which Stefan could not finish fixing. The rest of the video is now on this matter. A short disclaimer in this on this video: I am not as professional as Stefan is with YouTube, so all these videos are taken out of hand with my mobile phone and all cut together in a makeshift operation. So yeah, please excuse that you will not get the quality you might be accustomed to from Stefan. Now the tuner is on my workbench. Let's now check the tuner first. We see here the transceiver. We first now try to use the tuner. So we press here the tune knob, which is now creating a carrier signal. 8 watts, as we see in the right side, should be enough for the tuner. So let's now go over to the tuner. Here we see the tuner. And now let's apply the tune button. Oh, increase power. That is not correct. Let's see what's the problem with the power. Let's make some measurement first. Yeah, this is now the unit which is doing the measurements. You see, I have applied an oscilloscope probe here on the incoming signal line, also the ground applied. Now let's go switch over to the oscilloscope and see what is visible if we switch the tuner on. We see a nice signal, 22 volts. At 8 watt we would expect something like 26, but this is due to the not ideal load here. In this case, it's in the range, it's fine. So what we see here is okay. So the next measurement is now behind this small transformer, parallel to the resistor 64. This resistor is here coupled with this transformer that you see on the left. It has a winding relation 1 to 15 by 2, as it is 2 halves. So what do we expect here? After a short calculation, we expect here something with 8 watts, something in the magnitude of 1.2 volts between the ends of this resistor. This resistor is not constant to the ground, so we have to pick it up with two probes and calculate the difference. Fortunately, the oscilloscope is doing that, so we see here yellow and blue, and in the middle we see the purple line, which is the addition. Here we see some signals jumping in, but now we see the real signal. And what do we see? 1.3 volts across the transformer. That seems about right. So far so good. Then let's see what happens behind the diodes. Here we see now the probes connected after these Schottky diodes, which are then rectifying the signal both for the forward and reflected signal. So we see up the reflected, you see the REF on the right, and below is the forward signal, which is built by this component. And now let's see what these voltages are as we look to the oscilloscope. Currently, of course, nothing, as we have not yet switched the carrier on. Now we put the carrier on and oops! We see full sine waves after a diode. We see some distortions. That is not the problem. This is incoming signals from the antenna. But this should not be the case. It should be equalized. We should, also with the capacitors at the end of the diodes, we should see here constant voltage, not a sine wave. So likely we have a problem with these diodes. Let's dive deeper. Let's dive deeper now. Now let's measure the diodes. So in this case, on the reflected diode, we see 160 millivolts. That is low even for a Schottky diode. Let's switch the polarity. And now with the switched polarity, 185 millivolts. So this diode does not look really good. Let's check the other one. Now the diode on the forward path, 240 something, and let's now also see for the reverse. In the reverse path we see here 210. So it does not all look very promising. I think we can immediately compare that to a brand new diode. So the new diode is 368 millivolts in one direction and as expected completely off in the other. Yeah. So let's try to replace the diodes. I don't have the right types here, so these here are only good for 35 volts, but at least for a first test that should be sufficient. Now we desoldered the diodes and let's see what happens to them. Let's check the diodes in their own. 113 millivolts, and I don't need to show you exactly the same way opposite. And now again the same procedure. After we have exchanged the diodes, let's switch on the carrier. Carrier is on, and now let's press the tune button. And it tunes, and we have the frequency. Problem solved. Was only the diodes. Simple reason, big issue. Now a short explanation of what we saw and how this all works. So the clock input that we see here, which is going in this PIC microcontroller, go through a pre-scaler and then finally into a counter, which is a 16-bit counter, counting low byte, counting high byte. So far pretty normal. What is up but also interesting is this pin is not only the input for a clock pin, but of course also a GPIO output pin. And so this GPIO input or output can also do some output functions while this part here is doing its timer counter functionality. And this was the reason that what Stefan found in the beginning, that this clocking signal seems to be unreliable. But it was of course not unreliable. The idea is that the frequency is typically done by a gating function. So we count the amount of impulses which happen within 1 millisecond. And if we count for exactly 1 millisecond, then we get the frequency in kilohertz. And to have this very exact, the software in this controller is holding low the pin with the GPIO, while it is now, of course, setting the counter to 0, preparing everything. Then it is releasing the GPIO, and now we see all the pulses. And after exactly 1 millisecond, the counter is again, the pin is again pulled down by the GPIO. This means the counter is now stopped, and now the system has time to retrieve the counter values and so on. So far so good, but there is another nasty effect that could happen. Of course, we have the situation there is key down or PTT, or we are in the tuning or whatever. And now here is the situation when key is up or PTT is released. And then, of course, our pulses stop. Now we would, of course, show an incomplete count, only a strange number, which is, of course, by far not the kilohertz that we expect. And as the tuner has no idea whether the key is down or whether PTT is pulled or whatever, the only possibility of the tuner is to look at the forward power. And so while the forward power is there, counting is all fine, but if there is forward power going down during this counting gate time, then this leads to the situation that the result is not shown. That was exactly the situation. So this was what was this with this tuner. So this tuner had, due to these broken diodes that I exchanged, had always power 0. And this has had of course then the consequence that these counting values were always dropped at the end of this counting period, and we saw 0. Very simple. And now we are back. The diodes BAT41 with identical values have been, as the original CSH 270 have arrived, and I placed them inside the tuner. So we have now the tuner back repaired. And now we see here now the final function test. So we see here the radio. And now let's switch on the tuner. And we see here the tuner. We see here the 000 megahertz. And now let's start the tuning here and the tuning there. And we have here the tuning. And the antenna is now fairly tuned, and now we can take off the frequency, the carrier here. Yeah, someone may now wonder, how do I get all this data of the tuner here on the computer screen? Yeah, that's the reason why I know this tuner that well, because I developed a small gadget that you can add to the tuner, and we will show that now. We see now here the tuner, and what we see here on the right is a small pitchy back board which is put in place of the MFJ PIC processor. You see the PIC processor again sitting on top, so the mounting is rather simple, no soldering, no modification of the device. Simply you take out the PIC, you plug in the board, and you put the PIC on top of the board, and that's it. And this is then interfacing to the computer with the serial communication line that this MFJ 998 anyhow has. And if we look here, you see here the serial connector also blinking, so there is some data exchange over this. And so all the built-in technology is used, and yeah, more details not on this video, but I did this board, and if you're interested, let me know. Yeah, and here we see a final close-up of this board, which really caused the problems. We see now here the small diodes again, the blue diodes. These are now this BAT41 type, which is now in place. And yeah, now the tuner is working as it should and is showing correct power values and counting the frequency as we expected from it. So the tuner can now be closed and sent back to the owner. Yeah, after removing my additional pitchy back board, of course.